AP Stats Quideo 4, Kevin Carter. Two antibiotics are available as treatment for common ear infection. Antibiotic A cures 60% of the time and costs $50. Antibiotic B cures 90% of the time and costs $80. So a company plans two different treatments. Plan 1, treat with antibiotic A first. If not effective, treat with antibiotic B. And plan 2, which is vice versa. A asks, if a doctor treats a child with an ear infection using plan 1, what is the probability that the child will be cured? If a doctor treats a child with an ear infection using plan 2, what is the probability that the child will be cured? For A, if plan 1 is used, plan 1 is treatment with antibiotic A first. If that's ineffective, treat it with antibiotic B. Since we know antibiotic A works 60% of the time and antibiotic B works 90% of the time, then we know that 0.6% of the time it will work. So that's the probability that they'll be cured just from antibiotic A, plus 0.4 is, of course, the probability of failure of antibiotic A, times 0.9, which is the treatment, which is the success rate of antibiotic B. So 0.4 times 0.9 is 0.36, plus 0.6 equals 0.96%, with, of course, 0.04%, of course, with a 4% chance that neither will cure. Plan 2 does the same in reverse, so it's 0.9% success rate plus the 0.1% chance of failure for antibiotic B times 0.6. 0.1 times 0.6 equals 0.06 plus 0.9 is 0.96, with a 4% chance that neither will cure. B asks to compute the expected cost per child when plan 1 is used for treatment. Compute the expected cost per child when plan 2 is used for treatment. So I created two probability models for each plan. So we'll start with plan 1. So the cost for antibiotic A is $50. The cost for antibiotic A is $50, and if it fails, then they still have to pay for it, but they will also have to pay the additional $80 for use of antibiotic B. So if the success rate is 60% of the time, then it's 6 out of 10, with the failure being 4 out of 10% of the time. That leads to an expected cost of $82. So if the cost for antibiotic B is $80, of course adding up to $130 if it fails. If it will succeed, if it has a chance of costing $80 9 out of 10 times and will cost $130 1 out of 10 times, then the expected value is $85. Finally, for C, based on the results in part A and B, which plan would you recommend? Explain your recommendation. The best plan is to use plan 1. Both plans have the same effectiveness, but plan 1 is expected to cost slightly less. So both plans, 1 and 2, have a 96% success rate, but Plan 1 is expected to cost around $3 cheaper than Plan 2. The data also this data was used to make this data used of course rule 1 of probability, and the multiplication for independent events. B for Plan 1 and 2 uses follows rule 1 of probability. They both add up to 1. And that is just about it.